Welcome to the second part of the lecture, in which you will learn how to make settings for tables and make migrations for these tables. Step 5. Using migrations to create the database. This involves generating and applying migration files to automatically create or update the database structure based on your code models. Migrations capture changes in your code, like new tables or columns, and generate database scripts. Creating the database. Run migrations to apply these scripts, creating or updating tables and relationships in the database. Before we do the migration, install Entity Framework packages. In Data Access, class library, accept the library Microsoft.EntityFramework Core.Tools. Except for the library, it must be installed in the project environment API. These tools need the entire application context, which only the UI project can provide. We will explain the 2 steps in this lecture in detail for everything we do. The first step is the code to connect to the database. The second step is creating files for relationships and restrictions for each table. In the upcoming lectures, we will not repeat the explanation except for the things we mentioned. We hope you focus in this lecture on how to prepare these important files and their benefits. There must be a connection to the database. Everything will be in the code from this environment, so we must make sure that there is a connection code in the app settings file. If it is not there, we will configure it. Step 1. Add a connection string. In app settings.json, add a connection string that specifies the database name and server. Here, name the connecting string with default connection and define server is equal your server name. Database clinic DB trusted connection is equal true. Trust server certificate is equal true. You can replace your server name and clinic DB with your SQL server's name and desired database name. I will my server with dot or name my computer. What does that mean? In a connection string for SQL server, you can specify the server name in 2 common ways. Using a dot, if the SQL server is installed on your local machine, you can simply use a dot to represent it. Here, the dot tells SQL server to connect to the local server instance, or you can using your computer's name. Alternatively, you can specify the name of your computer as the server. When replace your computer name with the actual name of your computer. This is useful if you're accessing the server over a network or need to be specific. Look here, I can take the server name form, SQL Server Management, and paste instead dot in connection string here. In summary, use dot for quick access to a local SQL Server instance. Use your computer's name if you're on a network or need to specify the machine explicitly. Configure DB context in startup.ics or program.cs. In ASP.NET Core 6.0 or higher, configure DB context in program.cs. Add DB context to the dependency injection container. Builder.services.addDB context. Clinic data context options. Go to options.use SQL. Server builder.configuration.get connection string. Default connection. We use the DB context service by adding this code. What does it mean? This line of code configures the dependency injection container in an ASP.NET Core application to use clinic data context for database operations. It specifies Add the DB context registers. Clinic data context in the DI container. Use SQL Server. Configures the context to connect to SQL Server database. Connection string retrieves the database connection details from app settings.json under the key default connection. This setup allows the application to interact with the database using Entity Framework Core. Step 2. Create configurations. 1. Create a folder for configurations. Inside the Data Access project, create a new folder named Configurations or any other suitable name. Create individual configuration classes. Create separate files for each table configuration, patient configuration, and doctor configuration. An appointment configuration inside the configurations folder. In these files, we will explain something noteworthy. We use the identity type configuration of object T, where T is class. This interface allows you to configure how each entity, XMaple, patient, doctor, appointment, is mapped to the database. The object T specifies an entity type. File, patient configuration.cs. Here, builder.husky go to p patient ID. Husky defines patient ID as the primary key for the patient table. And here, builder.property p go to p dot first name dot is required dot has max length 50. Configures the first name column is required. Ensures this field cannot be null in the database. Has max length 50. Limits the maximum length of the text to 50 characters. And we have in the field doctor configuration.cs. We will add this code. Builder.husky d goto d dot doctor id is primary key to doctor table. Builder.property d go to d dot first name dot is required dot has max length 50. Configures the first name column is required. Ensures this field cannot be null in the database. Has max length 50. Limits the maximum length of the text to 50 characters. And we have file appointment configuration.cs. We will add this code. Builder.husky a go to a dot appointment id to define primary key to appointment table. Builder.property a go to a dot status is required dot has max length 20. Configures the status column. Is required ensures this field cannot be null in the database. Has max length 20. Limits the maximum length of the text to 20 characters. Here in this section, the relationship is made between the patient and appointment tables, as each patient may have more than one appointment. Also, this code determines the relationship between the doctor and the appointments, as each doctor may have more than one appointment, where builder.has1 a go to a dot patient, meaning appointment is associated with one patient. That with many, p go to p dot appointments. Each patient can have multiple appointments. Dot has foreign key. A go to a dot patient ID specifies that patient ID in the appointment table is a foreign key. Builder dot has one. A go to a dot and doctor dot with many go to d dot appointments dot has foreign go to dot doctor ID links the appointment table to the doctor table through a foreign key doctor ID. Navigation properties like a .doctor and .appointments allow you to traverse the relationship in code. After configuring the tables, we want to call it in clinic data context. So update the clinic data context with this code. Explanation of changes. Separation of configurations. Each table, patient, doctor, and appointment, has its own configuration class inside the configurations folder. This ensures modularity and maintainability, as each configuration can be managed independently. Clean DB context. The clinic data context class now references these configuration classes, making it cleaner and more modular. Scalability. If you add more tables in the future, simply create new configuration classes and reference them in on-model creating. Conclusion. This approach ensures a clear separation of concerns, easy maintainability, and readability of the configuration files. Scalability for future additions. Now, your project follows a clean and professional structure suitable for large-scale applications. Run migrations to create the database. In Package Manager console, run these commands. Add migration to generates a migration file based on your DB context and DB set models. Add migration initial create. Update the database to applies the migration to create the tables in the database. This command creates the initial tables for patient, doctor, and appointment in the database. Update the database. Now, let's see the result of our work and whether everything was done correctly. Let's move on to SQL Server. Very good. The tables were created successfully. Of course, these tables will be increased more in our upcoming lessons. Summary. To ensure that the work is correct and that the settings have been completed successfully for the system to operate, we must ensure the following. Install Entity Framework packages. In Data Access Class Library, except the library Microsoft.EntityFramework Core.Tools. Except for the library, it must be installed in the project environment API. These tools need the entire application context, which only the UI project can provide. Define DB context and DB set properties. Add a connection string in appsettings.json. Configure DB context in program.cs. Run migrations to create the database. Conclusion. In this lecture, we have set up the foundation of the clinic management system by creating core models and a structured DB context. Using configuration files, we're ensuring that relationships are managed efficiently and professionally. This setup prepares us to expand the system with inventory management, orders, user roles, and more in the upcoming lectures. Evaluation. How comfortable are you with the process of setting up core models and DB context? Do you understand the benefits of using configuration classes for organizing relationships? How effective was the migration process in generating tables in the database? Preview of next lecture. In the next session, we'll move forward by adding models for pharmacy inventory and storage management. This will enable the clinic to keep track of medications, stock levels, and inventory transactions, laying the groundwork for a comprehensive inventory management system. This structure will ensure that each part builds upon the previous lectures, ultimately resulting in a robust professional clinic management system.